Have you ever dreamed of creating your very own jetboard or efoil? Today, we meet Christian Green, the creator of his own DIY jetboard, who will share his insights on how you can build your very own board from scratch.
Hello Christian, and thank you for joining me on our show. I know a lot of people were asking me to make an interview with you. A lot of people want to develop their own do-it-yourself jetboard. So it's a pleasure for me to see you today. Thank you for coming.
Thank you. It's a pleasure for me to be here also and talk about this project.
So I watched all your videos, but before we dive in, let's talk a little bit about your reasoning. Why did you decide to create your own board instead of buying the existing one?
I suppose I first saw a Jetsurf video. I think it was probably an official Jetsurf product, maybe about 4 years ago now, something like that. And I just thought, wow, that's really cool. And I was looking at buying one, but I've always enjoyed having like an engineering challenge, and I just kind of, I thought, well, why don't I try and build one, develop one. It seemed like a really fun project. And one of the things that I liked about the Jetsurf concept so much is that I'm an expatriate. I'm from England, but I've been living in Romania for the last 10 years. And when I was living in England, there's not the best surf in England, but you do get surf. But there's really great windsurfing on the south coast. So I was an avid windsurfer, and when there was waves, I would go surfing. Unfortunately, in Romania, there are no waves. We're on the Black Sea, it's a very small sea. If there are waves, they're very sloppy, not well formed. And there's very rarely wind here as well. So I bought some windsurfing gear with the idea of, going windsurfing once in a while. When I wasn't working, I could go to the seaside on the weekend. But after 7 or 8 trips of going there with this windsurfing gear on the roof, there was never any wind. And I was just like, this is, just really frustrating. And it was a couple of weeks later when I saw a Jetsurf promotional video. It may have even been on your channel, and I just thought, wow, I have to buy one. Then I was thinking, well, it's the winter, I can't really ride it now. Why don't I develop one, So that's how the whole thing started.
All right. So there are a lot of different directions. There are efoils, there are electric jetboards, and there are petrol. So can you walk me through the process? Which one you decided to start and why?
Yeah, sure. I decided to go first of all with an electric jet surfer board, as opposed to a foil. Primarily the reason was I didn't really have a foiling background, and I suppose, if you've never experienced something, then you can't really miss it. But living in Romania for quite a long time, I couldn't go surfing. I'd have to travel overseas to surf, so I missed that sensation of surfing. So I decided to go with an electric jet surf board to fulfill that craving which I had. And electric seemed like a nice, clean, fairly easy, sort of safe. You're not using combustible liquids. So it seemed like an easier thing to develop than a gasoline board. So that was my first board which I built.
Okay, so let's go through the process. I know you have a background in engineering, you have your own company developing exhausts here in Romania, right? I saw your promotional video, how you made the exhaust for Porsche, which is very impressive. So you have all these tools and professional equipment, but let's say somebody is just getting started and he wants to make his own board. What skills do they need to get started, even to think about it?
There are a couple of points to that. First of all, I do have a manufacturing facility here, but it's not a jet surf or a surfboard manufacturing facility. It's an exhaust manufacturer and carbon fiber manufacturing facility. So we have as somebody would have seen from watching my video, my DIY build video. In the background, you can see there are CNC mandrel pipe benders and all kinds of crazy machines, but I didn't really use any of those machines for this build. Essentially, my build, 90% of it was very much a DIY kind of a build. There are a few tools which I use, like a lathe, and I used a CNC for one part to make molds. But there are ways around this. You don't necessarily need this as a DIY project. So the way that I built both of my boards was that I used a sort of a method which is very similar to traditional surfboard and windsurfboard building. Whereas you start off with a piece of foam. Traditionally it would be polyurethane foam, but I used expanded polystyrene. And then I used a couple of templates and a hot wire cutting tool to sort of cut the foam out into its basic shape. And then I did shaping by hand, the classic board shaper thing. You sort of look down the board in a certain light and you smooth in those rails and get it into a really nice shape. I'd like to stress that I'm not a board builder. These are the first windsurf surfboard, jet surfboards I've ever built. So for me, it was like a learning curve. I watched a few videos, tutorials on guys that build windsurf boards and build surfboards and applied the same kind of techniques basically, and then laid over wet carbon fiber, which again is a process that you don't need a lot of tools for. You just need hand tools like a paintbrush and some resin and some dry carbon fiber fabric material and some sandpaper, and you can make a hot wire cutter. If you get a piece of steel wire, I used Inconel wire because that's what I had lying around. You can set up a wire cutter. Go on YouTube and search, like homemade wire cutter. You just use a car battery, well not a car battery, but a car battery charger, and you can cut that blank out quite easily. For me personally, with my board, I built pretty much everything from scratch. So obviously, if you take that route, it's going to be quite a technical difficulty, quite an achievement to really do that. But you don't necessarily have to do that. For example, you can buy Jetpumps, which are already made off the internet. There's a couple of companies, MHZ Watercraft, I think, does one, and there's a handful. And you can take those already made components. If you want to make it really simple, you can take some radio controlled batteries with a high potential sort of current draw. You don't even have to make your own battery pack. You can do it from a fairly low DIY perspective. Or you can even just buy like a windsurf board, and then you put in the MHZ jet pump and you buy some high current discharge RC batteries for planes or boats or whatever, and you can make something that will work like that. But I was kind of in a development project. I was thinking about manufacturing these things. So like, obviously I don't want to be buying in components from other people, and also it had to be able to I had to come out with a product that was, you can do full throttle and you can do that for 45 minutes of ride time, and it has to be safe. So in order to do that, I had to sort of develop my own parts. But you don't have to have that amount of engineering, sort of ability. There's a whole different spectrum of difficult or easy ways of making your own jet surfboard.
So we know that commercial boards, and they start from 10,000 and even 15,000 euros to buy. But if you start with do-it-yourself, buying the components, what budgets are we looking at for people to get started to buy those components?
Yeah. Let's take a really beginner project for a start, and then I'll end up more talking about my project. But a really beginner project. Let's say you get a windsurf board. You can pick it up on eBay or something, or a second-hand online, wherever, for maybe 100 euros. And windsurf boards, by the way, make really great jet surf boards because they have a lot of volume. So it means that you don't need as much power to get planing. Like the more volume you have, the more easily it will start planing. And also because they have no tail rocker, they have a very flat tail. So again, this is like a very efficient way that you can move over flat water. So anyway, you buy a windsurf board for 100 euros. Maybe you can pick one at Evon up for 50 euros. Say you buy an MHZ kit. I'm not sure how much they are. I think they're about 2,500–3,000 euros. But that gives you the motor, the speed controller, and the jet pump. And then you just buy some RC batteries. And that's basically pretty much the total build cost. And for that, you can get something that works fairly well. Like if you want to add more batteries, obviously you'll get longer ride time. And the more batteries that you add as well, it means that you can, ride it harder with more full throttle without everything overheating. And if you've only got a couple of batteries, you have to ride it for like 3 or 4 minutes and then stop. But if you invest in more batteries, then you can ride it for maybe 15 minutes before things start getting a little bit too hot. So yeah, it's for probably like 4,000 euros. You can get something, 4,000 euros. You can get something that's going to work quite well. There are alternatives to the MHZ. You can buy speed controllers from China. I tried a few. They work, but the cooling isn't really adequate in them, and you either have to come up with some kind of additional cooling on the MOSFETs, or an alternative is you can just buy several of them and run like twin jet pumps, or even like a twin jet pump setup. But like the way that I went with my first electric board is that I bought a Chinese motor and a Chinese speed controller, and they were quite cheap. I think I spent probably about 500 euros, like for both the motor and the speed controller. And I built the board, I built my own pump, I built my own propellers and stuff like that, and I built my own battery using 18650 cells. Like it worked first time. I got up and planing, and it was great for like 5 or 6 minutes, maybe 8 minutes. It was like, wow, this is amazing. It just worked first time. I can't believe it. And then there was a big like woo kind of a sound, and the motor fused and the speed controller blew up. So I went through this whole fiasco of trying to rewind my motor. I'd never rewound a motor before. I thought, wow, how hard can it be? Tried it, same thing happened, blew up within a few minutes. So I decided to go the route of like proven, tested, European-made electronics. So I went to a company called MGM for the speed controllers, and I went to Lerner Motors for the motor. And the reason for that is because doing a bit of research, you discovered that they're kind of the best in the industry, but also because MGM was supplying Radin, the Radin Wakejet with their speed controllers, and MGM was supplying, and Lerner was supplying another manufacturer, a German manufacturer, I forget their name. But anyway, they were proven components. So I decided to go with these components. The motor cost me about 900 euros. The speed controller was about 900 euros as well. And then I built my own huge battery pack, which is a 14S16P with 250 18650 cells. Took about 250 of these cells here. And I suppose that ended up costing me about the same as having an MHZ kit. But the difference was that I got the battery included, and a really quite a sizable battery. So I was looking at like about 35-40 minute run times with that setup. So again, that was about a similar price to buying the MHZ kit. But obviously I saved quite a lot of money by not buying a jet pump and stuff like that. So if you want to buy a jet pump, you know it's going to cost a bit extra. So it depends how much you make. If you make more of it yourself, you can build it for 3,000 euros and you can have like an industrial level Jetsurf board. Like my electric one did 55 to 58 kilometers per hour. You got 40 minute run time. It's equivalent to like a Radin or something like that. You know, but whereas if you buy the kit, you're going to get ripped off a little bit more. You know, it depends how much engineering you can put into it.
Okay, so you mentioned the battery, and I saw one of the main questions of our followers was about the concerns of the battery safety. There have been a lot of battery fires lately in the industry, and waterproofing of the battery is the biggest concern, as well as overheating. So how are you solving those issues?
Yeah, overheating with the electric board was a big problem with the battery, but also with the motor and the speed controller. So the way that I went about heat management was I had to machine quite a lot of heat exchangers. So I've got a couple here I can show you. This is a secondary heat exchanger for my motor compartment. So like water goes in here and it's got fins on it to help, you know, conduct more heat as the air is sort of moving over. There's another motor heat exchanger that I machined. Again, we have water cooling nipples here so you can feed water in. And then there's another battery heat exchanger here. This is my carbon battery like compartment lid. And there's a huge heat exchanger that the batteries would sit against. Then there's another heat exchanger underneath that. So it's conducting heat above and below the batteries, like all being powered from the water pump. And then there was heat exchangers inside the motor, another one inside the speed controller. So I had like 6 heat exchangers by the time I finished my electric board project. But I didn't start out like that. I started out with only water cooling on the speed controller and on the motor internal. And that's great. You can ride for like, you know, maybe 7 or 8 minutes before your battery begins to overheat and before the external part of the motor begins to overheat. But if you wanted to do what I wanted to do, which was to have 40 minutes, full throttle, hard riding, you know, and keep things in you know, like within check, you had to have a really good heat management system. Now, I think probably knowing what I now know, if I built another electric board, which I may do in the future, I'm not sure, I think there are better ways to manage the heat than what I did. But what I did is I just kept on adding more and more heat management, another heat exchanger here, there, until gradually my motor was cool, my speed controller was cool, and my battery was being kept cool. So heat management is kind of a problem if you want to, you know, if you want to thrash your board, and if you want it to perform like an off-the-shelf board, like a fully developed board, you're going to have to think about heat management. On the other hand, if you're not really that concerned about that as a DIY hobbyist, and you don't mind riding for 5 to 10 minutes, let it cool down, ride another 5 to 10 minutes, you can go less crazy with the heat management systems. But yeah. Also, you mentioned about the sealing of the battery compartment. The way that I sealed it was like this is the lid for my battery compartment, and there was a mating surface around here on my board. I'll send you some additional film of that. And then I had a rubber gasket here, which, if you look closely, it's got like locator holes in it. This is where the locator bolts went through. And this simply made a watertight seal between my motor compartment and my board. And this obviously sticks to the board. You can silicone it down or whatever, or it will stick itself just through compression and friction. It's a fairly simple solution, really. So as a DIY guy, you can do something like that. For a production board, I would have used a similar method, but a slightly more developed method. This is just kind of a quick, easy method for me sealing without really worrying about it. And then finally, on the safety of the battery, yeah, this is another potential problem. For me personally, I made a bunch of smaller battery modules, and I was running 8 of these. This is a 14S 2P battery, and I was running 8 of these, so it became a 14S 16P pack. Now, I wouldn't really recommend necessarily you make small modules like this, which you then, you know, connect with in parallel, because if you have a certain amount of discharge between one battery pack and the next battery pack, you're going to get sparking and arcing and a lot of current flow between them. But the reason that I did it this way is because I wanted to know, like, I didn't know how many cells I would really need to make a production quality board. So I started off with 6 battery packs, realized that wasn't really enough, so I added another 2 to bring it up to a 14S 16P battery, and discovered it still wasn't really enough, that I was over discharging the cells. So using this method, I could add more. You know, I could easily add 2 more battery packs if I needed a bigger battery, but it's much safer to have a single big battery pack, because you avoid that when you connect it, you know, sparking and large current discharge. But there are also other safety features. On the side of here, we've got a battery monitor stabilizer circuit, and there's one on each of my battery packs. So you need to have a BMS on your battery. You can go on, you know, on YouTube or Google and you know, search for BMS, and there'll be descriptions there. But it's essentially a safety device, and it means that, you know, if you store your batteries for a long time, they will be discharged to like a nominal sort of charge state. And it also, you know, helps prevent overcharging, catastrophic failure, etc. Various different BMSs offer different levels of safety, but it's definitely worthwhile looking into a decent quality BMS so that, you know, your battery is stabilized and it's balanced, and you're not going to run into any danger, or you're less likely to run into dangerous situations. And then on top of that, you really want to, you know, get some good insulation on it. I've got some, you know, like heat protective films within this, and then heat shrink on the outside, and, you know, just so that we don't end up like shorting out the actual ends of our cells and our heat exchangers, or if you make it from carbon fiber, will conduct electricity. So, you know, you have to get good insulation on these batteries. And then after that, just if you're not using heat exchangers, just monitor the temperature of the battery. Make sure, you know, it doesn't get too hot. If it's your first time riding a board you've built, like literally ride it for 2 minutes and then stop and then check the temperature of the batteries. If they feel hot on the outside, like, you know, like a little bit too hot to touch, that means they're definitely too hot on the inside and you need to stop and let everything cool down.
Let's cover also the jet pump. I saw in commercial boards there are different combinations. Some use 2 jet pumps, some use like a Wake-Ravik really big jet pump that is under the board. Some like Jetsurf there is inside. What's your opinion about jet pumps and which power you need to get planing?
Yeah, you need to get planing with a fairly large volume board. You need about 7-8 kilowatts of power, I would say. You can divide that between 2 jet pumps, or you can go for a single jet pump. I decided, for me personally, it seemed more economical for me to go for a single jet pump. The reason being that as I said, I bought a single large motor for €900 and a single large electronic speed controller, and these are both industrial grade items, so they're like some of the best within the industry. It cost me €1,800. Now, if I went with twin jet pumps, it's pretty hard to find like a combination of 2 motors that would be equivalent to the Lerner motor and 2, you know, speed controllers that would be equivalent to the MGM for anything like that kind of money. So you end up spending more. Now, yeah, can you go cheap? Can you buy some cheap Chinese motors and you get 2 motors and you know, you're running 2 cheap Chinese electronic speed controllers? Yeah, you can do that, but it's not going to have the same durability. So that's the reason I went with the single jet pump. Is I decided just to buy an industrial grade motor, industrial grade speed controller, single jet pump, because obviously if I had 2 Lerner motors and two MGM speed controllers, I'm just going to be overpowered. You know, I'm going to have like 40 horsepower, which incidentally my gas board is 40 horsepower. It's crazy. So yeah, so in my opinion, I would go with a single jet pump. Unless you just want to toy around with something for 2 minutes and you're only going to use it twice, then maybe go twin jet pump and buy really cheap components. But you want something quality that will last, I would go with single jet pump.
And finally, in case of electric board, what about the remote control? I saw some people use Maytech remote, others complain about it. What's your opinion about remotes?
Yeah, I used an off-the-shelf solution. I think maybe it was a Maytech controller to start with, just because I wasn't really interested in developing that part at that point. I was more interested in the mechanical and the board side. So I took one of those. First of all, I had a big RC radio control car thing, you know, with the knob on the side, which is just completely ridiculous. You know, I put it inside of a plastic bag. Oh no, in fact, actually the first thing I used was a servo tester, because I didn't even have a controller at that point. And then later on I saw the Maytech controllers, but they weren't very ergonomic in you know, in their functionality. So I took the electronics out and I 3D printed a case for it. Now, it's not waterproof, so I had to put it into a bag. But it works, it's pretty functional. Another quick point as well, because my board was carbon, radio transmitter signals don't pass through carbon, like really at all. So what I had to do is I had to, that's where my where my receiver is. There's a little machined aluminium thing there that you can bolt in. And then on the other side, because this is all carbon, it blocks the signal, we've got a 3D printed like module that sits on the top, so that the signal can pass through. So, you know, when you've got the remote above, it passes through more easily. Now, going forward, if I wanted a production ready board, of course, this wouldn't suffice. I'd need something with, you know, like injection molded with, you know, proper, you know, sort of silicon gasket seals or something on it. But for a hobbyist, yeah, it works pretty good, and it's got a nice modulation to it, a nice feel to it. Yeah, so that worked pretty well.
So let's cover also your petrol board. What engine were you using? And you made your own exhaust, I saw.
Yeah, it's a Vortex DDJ engine. I think it's called a DDJ. It's an engine which isn't in production anymore. So I think the DDS or the OKJ are like equivalent engines from Vortex now. If you go on Vortex kart racing motors on Google, you can find them. You can find them secondhand on eBay probably as well. But it's like a racing kart, like an FIA racing kart engine. And I bought it specifically because it's of the like push to start variety. So there's it's a single speed, so there's no gearbox on it. So it makes it more lightweight. So it weighs like 14 kilos. It's 38 horsepower, and it's just this crazy screaming motor. So when they're on go-karts, they race them in like European championships and stuff. And these karts are doing like over 100 kilometers per hour, 120 kilometers per hour. So I thought, yeah, that seems like a really cool engine to put into a jet surfer. Now it's 125cc, so it's not quite as compact as the engines used in jet surfer and Mako and stuff like that. But I thought it was a good place to start just for a prototype board. So yeah, my board ended up a little bit heavier because of that engine. My board is like 30 kilos in total but my God, it's so fast. It does like 75 kilometers per hour. Because the engine is a little bit bigger than the jet surfers, like my jet surfer is a bit fatter, and because the rails are not so beautifully sort of, sculpted like on a commercial product. Like the rails are a bit fatter and it doesn't have quite the same turning, like you can't carve it quite so easily. It's really difficult to carve it like really hard. So that's the kind of drawback I suppose of having a fatter motor. So going forward with that, like if I really wanted a project, maybe I would design and machine my own two-stroke motor, like a really low profile one, but that would just be me, a crazy winter project if I ever did it,
And you made your own exhaust. Tell me more about your exhaust that you made.
Yeah, well, I own an exhaust factory, so and we work in exotic materials like titanium, Inconel, stuff like that. So it's kind of my forte. It's kind of my expertise, really, building exhaust. So yeah, I built an exhaust which is a coolant pre-warmer for the engine, because obviously you can't just put freezing cold water into the engine. It's going to be very bad for it. It has to be pre-warmed. So the water from the jet pump pre-warms in the exhaust, whilst also cooling down the exhaust, so the exhaust doesn't get too hot. Keeps the engine at a nice temperature, and it's also a noise suppressant, obviously. I haven't actually perfected the exhaust 100%. It functions as a water, like sort of temperature moderator, but I'm pretty sure I can get it quieter. It's pretty loud right now. I've gone through 3 prototypes of the exhaust. The first one was like horrifically loud, but had a valve in the top to stop water from getting in. I decided to ditch the valve altogether because I had a top-mounted exhaust anyway, and I came up with a second design which was, significantly quieter, and then a third design which is significantly quieter again. But I'm pretty sure I can get it a lot quieter if I do a 4th iteration of it. So maybe I'll do that, in the spring, ready for the summer. We'll see what happens.
And the question that is always interests me is, a lot of companies make one prototype or several prototypes that kind of works well, but they really struggle to start mass production. What do you think are the main challenges and differences between like making one prototype that works and then going to mass production?
Anybody can build a prototype to an extent, but using like handcrafted techniques and stuff like that. The problem is that it's not cost effective to then sell that product. In order to make it cost effective, you have to bring the cost down, which means you have to be able to produce volume stuff very quickly. So that means that you have to, invest in tooling. You have to machine all kinds of tooling for the carbon fiber. Like you have to train guys, to do the assembly. You also have to have like literally a perfect production ready design as well. So all of the prototyping I did with batteries and everything, and with this modular battery design where I can add more, and heat exchange and all this kind of crazy stuff was trying to get a prototype board to function in the same way that, you know, a production board would. I.e., you know, you can rev the crap out of it all day, and it just takes it, or you know, you get it to like a safety point where things are not breaking, or this is quite difficult. You know, also it's easy to make a board that breaks down all the time. It's difficult to make a board that really is safe and foolproof and performs, and you know, is worthy of being on that market. And then even after you've come up with that prototype, it's then the cost of machining all of the tooling, you know, setting up a production line. This is quite difficult, and I think quite a lot of, you know, the people that started some of these jet surf companies, like especially with the electric boards, I think they thought, oh, this isn't going to be too hard, and maybe making a prototype isn't that hard, but getting the prototype refined and then setting up a manufacture procedure, this is really hard. You know, it took me with the exhaust and carbon fiber company, it took me, you know, 7 or 8 years before the manufacture process really like worked without my input. The first 6-7 years, it was just, I had to be there constantly overseeing things, you know, constantly dealing with the difficulties. It's only now really that it works without my intervention, you know.
All right. So to wrap everything up for guys who want to start and make their own board, what are the main steps and main challenges that you suggest to pay attention to? And like, what's the easiest way for them to get started making their own board?
Yeah, first of all, decide what level of engineering capability you can do. And I would suggest that don't bite off more than you can chew. I mean, like I went a bit sort of, you know, in depth with my build because I'm an engineer by profession, and I you know, I decided that's the level of involvement that I wanted. So decide what level of involvement like you can really put into it. If you're building it in your garage on the weekends, maybe, you know, try going with an off-the-shelf jet pump, and you know, maybe even try going with off-the-shelf batteries for RC cars. Then if you decide you want more performance, then maybe, you know, have a go at making your own battery pack, but really research it. Research on the internet how to make battery packs, and you know, like how to do all this kind of stuff, because it you know, like preparation is really key in being able to achieve something like this.
All right. So the final question: what's the future for you? What are your next plans? Are you planning to make a new model, or efoil? Let me know what's in your plans.
Yeah, right now my company has just become so busy with this COVID thing. It seems like everybody is buying exhausts for their supercars. So like we've just become so busy. So I literally don't have time to really do this project, you know, to sort of take it on any further right now. I will, however, be riding all summer my gas board because it rocks. But I don't have any plans immediately to really put anything into production. If I do put something into production, it will be electric, because there are benefits of electric over gasoline. There are drawbacks, but for a start, you can lay on the board and submerge it, and it's not a big deal. So you've got the safety element of, you know, if somebody's a novice rider, it's much easier for them to ride. Electric is the future. Battery technology will only improve. I think they're easier to manufacture low volumes, whereas developing my own gasoline engine and then putting that into production is going to be quite difficult. So if I do a production board in the future, it will be electric, but it's not going to happen in the next 6 months. So for now, it's just going to be riding my gas board down at the sea, and that's it. Although I do have constantly crazy ideas about how I can, you know, make a better electric board, or how I can more easily make molds for the actual board rather than machining a huge block of aluminium. There are constantly ideas coming into my head about how I can improve it, but right now I just don't have that time to really execute, you know, to really do it. So
thank you so much, Christian. And if anybody wants to make an exhaust for their exotic cars, they can go to your company, Klein Exhaust Boutique, right?
Yeah, Klein Innovation Exhaust Boutique.
All right. Thank you so much again for your time. I really appreciate it, and I hope people will find it helpful.
Great. Thank you very much, Mike. Cheers.
Okay, cheers. Bye.